Thanks, everyone. Okay, so before I do anything else, well, yes, hi, I'm Harriet. Probably should start with that, shouldn't I? But I'm also going to bring 4 willing volunteers up to help me. 3 of them I've already arranged ahead of time. So Andy, Andy I'll bring across, but can I bring up also Amanda and Corey, please? Give them a round of applause. Amanda, if you go far table there. Corey, either of these near 2, please. I just want to keep an eye on you. And I'm going to bring up a completely on-the-day volunteer just to prove that it isn't entirely pre-planned. So can we welcome Naomi, who I jumped on at lunchtime. Naomi. So Naomi agreed to do this sort of like less than 2 hours ago. So thank you very much, Naomi. Okay, so if I stand back here, you can still hear me, right? It's all fine. Okay, good. I feel like I'm right. Okay, so here's what we're going to do. This is slightly gimmicky. Well, yeah, I don't know. This is a demonstration or a gimmick of some kind. And I'm going to open my talk with this. Okay, so just bear with me. It will all become clear slightly later. Each of these 4 willing volunteers are going to have a task that they need to carry out using a shared pool of Jeeplo bricks. They're in front of Amanda. I'm not sponsored by Jeeplo. Other stackable blocks are, of course, available. Each of these guys are going to have 90 seconds to achieve their goal, and whoever has completed it to the best level when the time is up will be the winner of nothing. Okay, so here are the tasks that they have to do. So, player 1, that's Amanda over there. Amanda, give us a wave. I think we know who Amanda is. We're happy we know who Amanda is. Amanda is going to organize the pool into colored piles of blocks and return as many bricks as possible that have been taken by other players back to the pool that's in front of her. Amanda, is that okay? You've got the bricks in front of you. That's what those are. Awesome. You can take when you run out of what's in front of you, you can move and take as many as you want. Okay, cool. All going very well so far, isn't it? So that's her role there, okay? Player 2, Corey, give me a wave so we know who Corey is. This is Corey. Corey is a lovely colleague of mine. His job is to build as many weird sculptures as possible, okay? Make sure they're suitable for work, please, Corey. This is a family-friendly conference after all. He is only allowed to take bricks from Amanda's collection to build with. Okay, that's his rules. And Amanda obviously has got to try and get them back eventually when she's at a point of her color sorting. Okay, player 3. This is Naomi's job. Naomi, give us a wave, thank you. Naomi's job is to build the tallest tower that she possibly can. She is only allowed to use bricks from her own private collection on her table to add to her tower. So she has to basically be collecting a private collection of bricks on her table. And she can only fill up her table again with bricks from Amanda's table when her table is empty other than the tower. Is that okay, Naomi? Yeah, it has to be. You're here now doing it. You have no choice. Okay, Andy's job. This is obviously a likeness of Andy that I've also put on the slide there. So Andy's job is to... Oh, he's got the glasses to match. That's so lovely. Andy's job is to order everyone's work by keeping record of the number of bricks that are being used in the structures by each player, and he's going to display the current total to the audience, hopefully using the big numbers I've got on paper cards. Sorry that they're not huge, but we will cope. When Andy is counting the bricks of other people, that builder is not allowed to build. So when he's counting at your table, he's going to give you the loading signs that they're in front of you, and you're going to have to hold those up. Andy can remove bricks from your structure to count them. Everyone okay? Andy okay? This is going to go so swimmingly, I know it. Okay, so this is what everyone needs to do. This is everyone's job at once. They're going to have 90 seconds to do this. Audience, are we ready? Volunteers, are we ready? Okay, good. Amanda sounded really confident and confident no one else did. This is why you got the big job. Right, okay, and we're going to start building in 3, 2, 1, go! If you've seen the Lego movie, great soundtrack. Okay, Corey's off to a quick start there. He's got a handful. You've had about 15 seconds of your time. Amanda's doing some good sorting over in her corner there, I can see. We've got a yellow pile starting to form. 8, says Andy. 8 bricks so far. So running back. Oh, we've got some bricks on the floor, I think I heard. It's all chaos. 47 seconds to go. No, Amanda, you can't touch what he's counting. Breaking the rules over there in the corner. 38 seconds to go. We've had a tower collapsing over here. It's all chaotic. Amanda's loading. Oh no, she's back on again. Corey's in loading mode. Pick up the sign if he's not giving it to you. Can't get the help here. 16 for Corey. Naomi, pick up the sign for me. Pick up the sign for me. Thank you very much. 16 seconds to go. Naomi's in loading mode while her bricks are being counted. 10 seconds to go, ladies and gentlemen. We've had some bricks stolen at this point. 3 seconds left to go. And that is time. Step away from your building blocks. Give them a big round of applause, ladies and gentlemen. Didn't they do so brilliantly well? As I said, you're all the proud winners of absolutely nothing, actually except for Naomi, who we do have a lovely Zivio gift bag for being an on-the-day volunteer. So Naomi can have a nice gift bag. Everyone else, thank you. You have my love forever. Let's clap them off the stage. Thank you so, so much. Okay. So after that bit of fun chaos, I think I should start doing some serious stuff, or slightly more serious stuff maybe. So hello, to start with, my name is Harriet Oughton. I am a senior developer at the wonderful Zivio, and I work with Ruby on Rails. I'm here today to talk a little bit about concurrency and threading in Rails. Why have I chosen this topic? Well, I have a day job working for Zivio, but I also work as a contractor for the Rails Foundation, as Amanda kind of nicely set me up for in her bit earlier on. And this means that I do a little bit of development work for the Rails Foundation, but I'm also, the major project last year was that I'm part of a small team who are working on the rewrites of the Rails guides. And I actually had the maybe slightly dubious pleasure of taking a really deep dive into the concurrency and threading guide. And all the learning and research that I did from that, I distilled into this talk. You have the burning question, probably all of you, about why on earth I had 4 members of the Rails community up here playing with Duplo to start with. I mean, firstly, who cares, right? That was just hilarious and great. But actually, we are going to come back to that question, so just hold it in your heads for a second, because, yeah, it's all going to become clear. In my previous life, so before I was a software developer, I was a classroom teacher. I was a school teacher for a long time. I have a master's in education, so maybe that's why the Duplo, right? It's like, once a Lego brick builder, always a brick builder maybe, but so I will bring some ideas from teaching probably into how I structure the rest of this, but I promise you I'm going to avoid doing too much teacher voice or giving out detention and all that sort of thing. But what I am going to do is set some objectives. So this is something teachers love to do. I'm just going to have these as our goals for the next kind of 15, 20 minutes or so. We're really going to get into what are concurrency and threads, what do those terms mean? Where is concurrency really inbuilt into the Rails framework? And actually, what does the source code look like? Like, where is this stuff, and can we read it? Can we see it? Where does it all come from? So some diagrams to start us off. So we've got, obviously, concurrency on the left-hand side there, and parallelism on the right. In terms of concurrency, so looking at the diagram on the left, a concurrent program, for anyone that isn't familiar, is a program that has tasks basically sort of starting and stopping, and essentially a program that manages how tasks are scheduled and executed. So this doesn't actually mean that necessarily the tasks are all running all the time at the same time. That's where you get that difference between concurrency and parallelism. That's why I've included that picture of parallelism. For parallelism, that's when things are in parallel. In concurrency, we've got this sense of managing the starting and stopping of tasks, and that's sort of the organization that needs to come with that. I'm not actually going to dive any further into parallelism today. This is just really there to throw a bit more relief on the idea of concurrency. And actually, this is where the demo starts to come into a bit more focus, because this is kind of what we saw in a very chaotic way. We saw an example here at the beginning of the talk of a concurrent system. Okay, we had 4 tasks going on at the same time, but in some cases there was starting and stopping, and there was kind of pauses, and not everyone was making progress with their task at the same time because of interactions and because of other things that were going on. We also witnessed a couple of bits and pieces in terms of the interactions between them, some of the problems that might occur that also have names that we might have heard about in software. So for example, race conditions. Lots of us have probably heard a developer shouting about race conditions, probably also while bashing their head against something solid. A race condition, so if you've not heard this term, this is when two or more parts of a program try and modify the same piece of data at the same time, and actually the end result depends on which of the modifications actually wins the race, okay? So it's not obviously a very stable thing. It's not a good thing to have. So in our case, for example, Andy's job of trying to total up blocks when there were blocks being moved around between tables, that number is going to be changed based on who's doing what at what time, okay? We also had the idea of resource contention. So you often get resource contention with concurrent tasks, or this can be a problem that can happen. With resource contention in the demo, basically we were all kind of fighting over Amanda's pool of bricks at the side there. That was we were all kind of going for those same resources at the same time. That's what you can see sometimes with multiple threads. And also, if we'd have structured the task slightly differently, I thought it would be really funny to have sort of like a taking idea. But if we had giving blocks between tables instead, we might have seen the idea of a deadlock. If you've not come across a deadlock before, this is where you might have process A who is waiting for process B, who's waiting for process A, who's waiting for process B, and then everything grinds to a halt, okay? So if Corey was waiting for Naomi, who was waiting for Corey, that would be the same kind of idea. So what? So, okay, why do I care about this, Harriet? Well, concurrency is great for many reasons. We generally love it in development for a few factors. Like, for example, the fact that we can take larger tasks, break them down into smaller tasks for much faster execution. Concurrency really allows us to make the most of our processing time. So, for example, if we've got the option to use multiple threads, it means we can do, and then we get a much faster response. It allows us to keep our applications really responsive. So, for example, you can display something to the user while you're doing something else in the background, and the user's happy. And also, it means that our input-output handling is so much more efficient. So no more waiting for APIs to return something or like a database connection, because we can actually do that in the background if we need to, and other things can happen in the foreground. So I've spoken a bit about threads, or I think I've used the term threads already as part of this talk. I'm just going to go into a little bit of detail about what that actually means. So a single thread is basically a line of work being done by a program. So in the picture here, again, thinking about the demo, each one of the volunteers, each one of the people in the picture are essentially one thread. If a program has multiple threads, it can do many things at once. Like I said, maybe we would have a video being loaded, and then we would have loading a feed on a page, so a user can scroll down the page, for example. Threads also share memory, so they do work together, but also this means there is a level of organization needed because we don't want them to start clashing. So what do they do in order to avoid clashing? Well, there is concepts called the stack and the heap. So again with the building blocks, you see I do like things from my teaching past. So all threads share the heap, which is where objects and data structures are stored. So this is, again, like Amanda's sort of pile of bricks that she had. This was the main collection of information. And the heap allows threads to read and modify the same data. But however, they also maintain individual stack memory. So I don't know if anyone noticed Naomi having to build from a little pile of bricks on her table. That's a bit like having an individual stack. And the point of having a stack is basically it's going to keep some individual operations separate, preventing them from interfering with everyone else's local tasks. So this is really preventing clashes between, or too many clashes between tasks running on different threads. But Harriet, you might all be saying, should I use fibers? Is this a thing I need to think about? Do I need to use fibers? I don't know. I don't know what your individual apps are doing, but I'm going to go into a tiny bit of detail here just to reassure some of us or give you kind of a top-line look at it. Basically, fibers are a lot more sensitive than threads because multiple fibers can run within one thread. And really, with this kind of top-level approach, I'm going to give the kind of key difference that we need to understand between a fiber and a thread is that a thread can get interrupted at any time, and another thread can take over. But with fibers, this only really happens when we as developers tell that to happen. So basically, in most standard Rails applications, probably for most of us in this room, I'm going to assume we're not going to need this really fine-grained level of concurrency management. So most of us probably won't need to think about fibers or worry about them once we leave the room and get to the pub. Most of us are only going to really need to think about it if maybe we are building something like a dashboard that might need to have many, maybe like hundreds of API requests in parallel. Okay, so what do we need to think about? Well, there are a few very familiar examples from Rails that we probably recognize, or we will probably recognize in terms of concurrency. Rails has actually been thread safe since the release of version 2.2 in 2008. And I was thinking earlier about how long ago this was because I was doing my undergraduate degree and now I'm incredibly old. So long time ago. And as a result, lots of processes in Rails are already concurrent. Hooray, this is such good news, isn't it? For example, this might be something that you recognize, this kind of code you might have in your apps or you might have seen before somewhere, because loads of us, probably everyone in this room, is familiar with the idea of a background job. And this might be the first example, maybe even, of concurrency that you came across when you were learning Rails, right? So in this example here, so you see I've got my processing job about in the middle of that controller action there, that process all action. I've got then processing job, and I've called perform later on that. And what I'm doing there is I'm using active job essentially to execute jobs in the background without blocking the flow of my app. So then obviously the code is going to continue through there, and we're going to redirect to presumably the items index, so we can show the user lots of nice things to buy or whatever it is. And actually the processing job is taking place without blocking us. This is fairly standard concurrency that lots of us will be used to. But good news, because Rails is actually also concurrent at even a request level. Okay, so Puma, which is the default server of Rails, is a threaded server. And every request to your app is actually given its own controller instance. And this means that all requests can be served simultaneously if needed. So I'm going to show you a quick demonstration of this. Don't worry, you can exhale. I'm not going to live code anything. I don't have a death wish. So I've done the code already. So I set up 2 requests. I set up a slow request and a fast request. Slow request on the left, fast request on the right, in the same controller. And they're basically exactly the same, except on the left, in the slow request, we have a 3-second sleep in the middle. And this is basically just to slow down the slow request and make it really slow. At the end of each of those actions, I've also essentially just rendered some information. So you can see I've kind of captured there the thread ID, the controller ID, and the start and finish time, just so we can have a little look at what's going on to prove what I'm saying isn't complete baloney. Okay, so what I'm going to do now is I'm going to attempt to, on these slides, to see what happens. I'm going to try and run the request in quick succession in 2 different tabs as close to the same time as I possibly can. See if it will run. Oh yeah, look, it's going. That's good. So yeah, you see I just made 2 different requests, slow request and the fast request in 2 different tabs as close to at the same time as I possibly could get them. And see if I can keep going without playing it again. Yay, okay, it's all good. And this was the output. So you can see from the timestamps at the top here that the slow request and the fast request broadly ran at the same time here. Right, the fast request ran while the slow request was still taking place, according to the timestamps. Also, we can see different thread IDs and different controller IDs. Slightly unhelpfully, the controller ID numbers are really similar, but they are different if you look carefully. So that sort of is proof of concept, isn't it? That actually we've got different controller objects, different instances, different thread instances for the 2 requests. Some of us might recognize this type of code for our app as well. This is perhaps some code that we might be using for chat room functionality. This code uses action cable, which uses concurrency to handle WebSocket connections efficiently. So essentially, each WebSocket connection will run in its own thread, and this allows a server to maintain many simultaneous connections without blocking. Some of us also might use asynchronous active record in our applications. If you don't already, or if you haven't seen them before, asynchronous active record queries can actually be performed in the background. So I've got two examples here on the screen. I've got sort of vanilla active record. I'm not sure what the term is, typical normal active record. And I've got asynchronous active record on the right-hand side, so you can sort of compare and see the difference. On the left, the kind of typical active record example will perform every query one at a time in order, and then we'll process the results at the end of all of that. However, in certain conditions, the example on the right, using load async at the end of each query, will give us the option for the queries to be processed concurrently in background threads. Also, the other thing which is really nice and speeds up performance here is that the data itself is only fully loaded when we attempt to access it. So, for example, when we're doing things like users query.count and .map and whatever else is on this slide there that I can't remember what I did. Yeah, map account and things like that. So this will really lead to improved performance, responsiveness, efficiency, scalability, like all those really nice things that we want. However, do of course use load async with caution if you're using it on a part of your app that's under quite heavy load. Because with load async, we're going to use more database connection threads in one request. So this might mean that one or a few users might exhaust all your connections and other users might have to wait or maybe even time out. So do use that with care. So what's actually going on in Rails behind the curtain, under the hood? What is it that we've got in the Rails source code that's actually giving us all these tasty features? I'm going to show you, first of all, a little screenshot from the load interlock class. Now, the load interlock class is in the active support module, and it allows, or basically this handles the kind of auto-loading and reloading in a multi-threaded environment. So you can, I appreciate you can't see all the context, it just gives you a flavor of what's going on. Basically, it keeps track of which threads are currently running application code or loading or unloading a class with really actually quite easily readable loading and unloading methods. In order to maintain thread safety, basically only one thread in most cases can load or unload at a time. And so to do that, basically it waits until no other threads are running application code. If you look at the bottom of this class as well, we can also see a permit concurrent loads method. Now, permit concurrent loads tells Rails that actually it's okay to allow concurrent threads to attempt to load a constant simultaneously in the cases that it's used. And this permit concurrent loads method might be used, for example, to prevent a deadlock when multiple threads are trying to load the same constant at the same time. We also have the Rails executor and the Rails reloader inbuilt with Rails. So basically lots of requests and actions in the Rails framework are wrapped with these, the executor or the reloader. And basically their job is to ensure that state is really properly set up before and after handling a request. And this is really, really important in a multi-threaded environment because it allows us to manage resources and really avoid issues like having data leakage or thread contention, things like that. The executor is used to wrap HTTP requests and is also used, for example, in active job, action cable, places like that are really, if you think about it, those are the main entry points into your framework. That's where you have lots of information or events interacting with the outside world. That's why it's really important that those threads are well protected. But in most other cases, actually, we only need to use the executor when additional threads are spawned. So again, most of us are never going to have to think about the executor and the reloader. They're just there in the background doing nice things for us, making our lives better and easier. Executors handle the setup and cleanup of things like database connections, caching, thread local variables, things like that. The only difference between the reloader and the executor is that the reloader additionally ensures that any HTTP request is served with a freshly loaded copy of the app in case there's any code changes. I'm briefly going to touch on current attributes. Many of us might not know what current attributes is. Again, this is part of Rails. And because we now know, we've learned today that requests are made in separate threads, current attributes actually gives us a way to store this request-specific data. For example, like who the user actually is who's making the request, or maybe the IP address of the request. And we can then access those values throughout our application in loads of different places without actually having to pass the value around from class to class to class to class. If we look in the Rails source code, which is the little snippet I've given you on the slide there, we can actually see just by in front of our eyes that it uses this thread.current to look at the particular data here, which is specific to that request.
Current attributes is also really nice because it cleans up all the data automatically as well after the request has been completed. If we were going to use this in our app in practical terms, what we would do is we'd set up a current class that would inherit from this active support current attributes class here. And we might give it, for example, the attribute user. And then we would store the user basically in the current class each time a request happens in our application. And then we would go on to call current.user anywhere else we want in our app to reference the current user basically in a thread-safe way with lots of the thinking and the preparation and everything done for us.
It is important to mention, I know there are critics, I can feel people's sort of shoulders going up slowly in the audience. There are critics of the current class in the community who dislike the way that current attributes creates kind of magic global variables that can be accessed throughout your app without really making it that clear where the data comes from. And some people have put out there that they think it makes code harder to understand and debug and things like that. It's sort of down to your individual use case really, and whether you think this is the right thing for your app. But here you go, it's there if you're interested in it.
All right, so now what? We're drawing to a close. I think it's time to think a little bit about some of the key takeaways from today, other than isn't Duplo hilarious and fun? I mean, that's a good one, but there are other things too. So firstly, concurrent processes is anything that starts and stops in a controlled way in software and therefore manages issues by the sort of controlling of the starting and stopping between different tasks. Also, Rails has loads of different ways to manage concurrency. So you can basically think about other things. Isn't that nice? It's super good. There's loads of concurrency inbuilt in Rails. For example, we've thought a little bit about active job. There's action cable, asynchronous active record, current attributes. In fact, all Rails requests, there's all threading by default. So hooray Rails, that's awesome. And actually, don't be afraid of looking in the Rails source code, particularly, I just showed you some of the concurrency stuff, but this actually applies to loads of different parts of Rails. Don't be afraid to have a look in the source code, even if you don't actually need to do anything specific, to it or with it. Just have a look, have a read. Hopefully you saw from the slides, it's really readable, it's really friendly. So go on the GitHub repo, have a little look, because it's really good to have a look and try and understand and try and see what's actually happening under the hood, and extra credit for feeling like a genius at the end of it. And of course, please don't forget to connect with me if you enjoyed this. So my Twitter handle is there, my X handle I should say is there, my LinkedIn, my email address. As I said, I have had the pleasure of working on the Rails, the threading and code execution Rails guide. The QR for the link is there. My PR is currently up, I believe. It hasn't been merged yet. So this is the old version of the guide, but if you look again in a few weeks, there'll be a newer version, which hopefully will be even bigger and bolder. This has been such an amazing honor and privilege. Thank you, Andy. Thank you, everyone, for listening.